So back at it today, we're talking about probability. So far we've talked about how many ways could something happen. Now we're going to see the probability of something happening, yes or no. Again, we could go for days, for a month, for a whole course on probability. We could do some really cool stuff with playing blackjack and slot machines and doing some gambling type things, understanding why it's a bad idea to do it because you lose a lot. We're going to do some base level stuff. We're not quite ready for all of that yet, but it's pretty cool. You can see where this thing's applied to and how they work. Again, we're going to do some base level stuff, see how that goes, and then work from there. So let's look at it. If we're talking about the probability of an event happening, okay, so the little p and then some event in the parentheses, we're trying to find the probability of something happening. To figure that out, you're going to take the total ways of being successful over the total number of possibilities. We're going to make a fraction. And so the best way to see this is a deck of cards. So let's say you are drawing one card from a deck of cards. What is the probability that you choose a king? So let's make a fraction. How many kings are there? So this is successful. What's the probability of getting a king? Well, this is the king column. There are 4 of them. 4 divided by the total number of possibilities. Well, how many cards are there in a full deck? There are 52. So 4 out of 52 is successful, so we could reduce that to 1/13. 1 out of 13 is the probability that if you draw one card from a deck, that it is going to be a king. Okay, let's keep it up. What is the probability of a king or a jack? So I'm still drawing out of 52 cards, but it's a king or a jack. In the last video, we talked about the word and how and means multiply. Here we're dealing with or. Or means add. Or means add. So it could be a king or a jack. Or in other words, how many total cards are a win? 1, 2, 3, 4, 5, 6, 7, 8. There's 8. 4 plus 4. Again, the or means add. There's 8 possible wins. Or in other words, 8 out of 52, we could reduce that to 2/13. I could divide them both by 4. You can also think of this. There's 13 columns, and 2 of the columns are a win. Probability of a jack or diamond. This is where it gets a little bit different. Jack or diamond. All right, so we still have 52 cards to choose from. We're picking one. Here are the jacks. There are 4 of them. And the diamonds. These are the diamonds. There are 13 of them. And so a lot of students will say 4 plus 13. And so there are 17 possibilities. It is not 17. Well, why not? Okay, the best way to do is look at this and count. There are 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 16 different possibilities here. Why is it not 17? Well, it would be 17 if I added them up, but I need to subtract any card that falls into both categories. So I'm going to subtract one jack of diamonds that falls into both categories. Otherwise, we count it twice, right? If we just did 17, I'd go 13 and then 4, and then you would count this card twice. Instead, we remove it, we subtract it. That way we only count it one time as we set this thing up. So it's 16 out of 52. If we divided by 4, we'd get 4 out of 13. All right, let's keep rolling along here. Probability of not an ace. Probability of not an ace. So again, we've got 52 cards to choose from. Not an ace. Well, here are all the aces. So that's not a win. That's not a successful event if I pick an ace. If I want the success of not an ace, it's all of these other cards that are not an ace. That is a success. So how many cards are there? Well, it's 52 minus these 4. So there's 48 cards that would make this successful. 48 divided by 52 is going to get me 12 out of 13. It's not always out of 13. We just had a lot out of 13. So don't let that be weird. That's the main idea. Hopefully you're starting to see what's going on. Normally when we write probability, we do write them as a fraction. We could make that a decimal, like 12 out of 13. We could do a fraction. 12 divided by 13 would get me 92%. There's a 92% chance that I don't draw an ace, but we're just going to leave it as a fraction right now. What's the probability of a king and then an ace? So let's do them separately. Let's find the probability of a king first. Well, there are 4 kings out of 52 cards. All right, so 4 out of 52, otherwise known as 1 out of 13. What's the probability of an ace? Well, there's 4 aces out of 52. Now, the question here is, am I putting that card back? And I'm going to assume that we're not. So let's do it this way. So we have 4 out of 52. And then, so we take that king, we set it to the side. It's no longer in my deck of cards. So how many cards do I have to choose from to get the ace? Well, there now is only 51 cards. How many of those cards are still an ace? 4 of them. All right. It's an and. I want this and that. So we're going to multiply those together. Now, this problem would change if we found that king and then we put the king back in the pile. So I wish they would have been a little bit clearer there. I'm assuming they are taking the king out of the situation. So 4 times 4 on top is obviously going to get me 16. On bottom, I'm taking 52 times 51. It gets me 2652. So 2652. And on top, I get 16. We could reduce it. Let's just leave it right there. Well, what are the odds of that happening? 16 divided by 2652. The probability of getting a king and then an ace is less than 1%, 0.006 or 0.6%. Really small chance that you're going to draw a king and then an ace. What's the probability of you getting a 5, putting it to the side, and then getting another 5? Well, how many 5s are there in a deck? Well, there's 4 out of 52 cards. I take that 5, I put it to the side. Now my second drawing, there's going to be 3 5s because there's one that I took out. And how many cards are going to be? Well, there's only 51. I'm multiplying those two together. So on bottom, again, I'm getting 2652. But on top now, I'm only getting 12 instead of 16 because it's 4 times 3. So it's even less probable that I'm getting 2 5s in a row. All right, keep that in mind here. Let's go down below. Same idea. Now you just don't need to know a deck of cards. You got 20 markers in a box. 8 of them are black. 4 of them are blue. 4 of them are green. And 4 of them are red. So I'm just going to draw 1, 2, 3, 4, 5. I can't do tally marks. 5, 6, 7, 8. 4 blue. 4 green. And 4 red. Why am I doing this? I have no idea. I'm just giving you a visual. All right, what's the probability of getting a red one, putting it back in the group, and then pulling a green one? So let's write 2 separate fractions here. What's the probability of getting red? Well, there are 4 reds out of 20 markers altogether. Cool? And then we put it back in. So we took this red, we got it, but then it's back in the mix. This and, so we're going to multiply the probability of pulling a green. Well, what's my probability of pulling a green? There's 4 markers out of 20 still. There's still 20 because I put that marker back. So when I multiply that together, 4 times 4 is going to get me 16. 20 times 20, that's going to get me 400. I could reduce 16 over 400. Yeah, that would be 1/25. You don't have to reduce. Feel free to leave it as 16 over 400 for right now. What's the probability of getting a red or a blue? Okay, well, what's the probability of getting a red? Well, 4 out of 20. What's the probability of getting a blue? Well, 4 out of 20. It's or. So what am I going to do with these two numbers if it's an or question? We're adding them because I want this or that. And it should make sense that there are 8 out of 20. There are 8 possible good answers out of a total of 20 markers. What's the probability of getting a blue? Putting it in my pocket and then getting another blue. So let's do the first one. What's the probability of getting a blue? Well, 4 out of 20. Putting it in my pocket. So I'm removing a blue and then getting another blue. So now it's and then, or we didn't say then, and, but then getting another blue. Multiplication. Now there's only 3 right answers out of only 19 markers left. So we're going to take I know what 4 times 3 is. 20 times 19, 380. So I got 12 out of 380. I could reduce. You don't have to, though. I'm fine with that. So again, what's the word that you're using? Are you using a few things we came up with here? Not something happening. Well, we're going to subtract from the total amount. There are 4 aces out of 52. So we got rid of that and left with 48. And when we see and, we multiply. When we see or, we add. And then the other thing is, are we putting the marker back in or are we taking it out? A lot of different things going on there. Hopefully that's starting to make some sense to you. Let's talk about playing the lottery. If you are to correctly guess 5 numbers that will pop out of the ping pong balls, you win $50 million. There are 40 different numbers. What is the probability of winning if each ball is removed after it's being selected? So imagine what you got here. You've got the little lottery machine. Oh my gosh, I tried to act like this is good. All right, this is a box full of lottery balls, little ping pong balls. Okay, and they're numbered different things. So this is the number 5, number 6, number 9, 40, 22, and so on. You've got to guess 5 in a row. We need to set this thing up. What is the probability of winning if each ball is removed after being selected? So, what is the probability that when they pick the first ball, you get the right answer? Well, there is only one right answer out of a total of 40 balls. So I got the first one right. 1 out of 40, I'm correct. Then I want that to happen, and I need to get the second number correct. Well, how many numbers are correct second? Well, there's only one number that's going to be correct. How many balls are left in there for me to choose from? Well, now there's 39 numbers because I can't repeat a number. Once I've used one, then it's gone. So this has to happen, and this has to happen. And then I need to get the third number right. So to get the third number right, I got to pick 1 out of the 38 remaining balls correct. And for that to happen, then I need to pick 1 out of the 37 remaining balls to be correct. And then 1 out of 36 of the remaining balls to be correct. I want this and this and this and this and this to happen, so I'm going to multiply. So it seems like a good old easy problem, but I get a 1 on top. On bottom, I get 40 times 39 times 38 times 37 times 36. Those 5 numbers, multiply them together. What is that? 7 million. Nope, just kidding. 78,960,960. 78,960,960. That is the probability of winning the lottery. You've got a 1 out of 78,000. And I think most lotteries go above 40 numbers. So you got to pay attention to that. You go above 40 numbers, now it's going to be even bigger. Okay, so paying attention to those things is important. Not real likely. Right? If you bought 50 million lottery tickets, you're not winning money back. What is the probability of getting the same 5 numbers if the ball is put back into the mix after each choice? Which one would you rather play? So imagine the same game, but each time I draw the ball, so let's say I could draw the number 1, and then I could draw the number 1, and then I could draw the number 1, and then draw the number 1, because I'm replacing the ball. It's getting put back into the mix. So on the first one, there's 1 right choice out of 40. And then the second one, there's going to be 1 right choice out of 40 balls still. And then 1 right choice out of 40, 1 right choice out of 40, 1 right choice out of 40. Or in other words, 1 over 40 to the 5th power. So I'm going to cheat here. That way I don't have to type all those in. But 40 to the 5th power, because it's 45 times. That is 102,400,000. That's what number goes on bottom, and a good old 1 on top, because that's the only number on top you have. Which game would you rather play? I'd rather play the first one because my odds are a little bit better. Still not great, but better than the second one. All right, so keep that in mind. Last one, a die is rolled 4 times. Find the probability of rolling 4 ones. That's what that means here. So we're doing 4 different choices, 1 and this and this and this. I need 4 rolls. Each time you roll a dice, hopefully you know there are 6 sides on a dice, so there are 6 choices. I want to get a 1. Be careful here, because what if I said the probability of getting a 2 of 4 twos? Sometimes a student will write a 2 on. There's not two 2s on there. There's 1 2 on top. Okay, and so there's 1 2, and then the next time there's a 1 out of 2 or 1 out of 6 chance, and then the next one there's a 1 out of 6 chance you get a 2, and then on the next one it's a 1 out of 6 chance you get a 2, or in other words, it's 1/6 to the 4th power. So 6 to the 4th, not to the 7th. 6 to the 4th power gets me 1,296. 1 out of 1,296 opportunities. That is the likelihood that you roll 4 2s in a row. So not very likely. If you ever played Yahtzee, you can see why that would be important. Hope that makes sense to you guys. Probability is crazy. Again, we could get super in depth. We're going pretty light right now, so don't try to get too overwhelmed by it. Understand the basics. There's tons of videos out there if you need some more help with it, or if you're just enjoying exploring and want to learn more, I would suggest doing it. Thank you.